Hi, I'm making this video for a few reasons. One, because I had a really hard time learning about plastic injection molding. I started about 2 years ago by buying old machines like this and just messing around in my garage. I found it to be a really fun hobby and also actually quite profitable. A lot of people don't really realize how easy it is to make a small injection mold and to run it in your garage and make parts. So this machine, I've actually got more machines since I got this one, and I might even post this one for sale eventually. So that's another reason why I'm making this video, to kind of document how to run this machine, because it's really old and I don't have a manual for it and I couldn't find one anywhere. So this is kind of in a way a how-to video for this machine for the person who may buy my machine. So anyway, to get started, I just wanted to first show it running a part, and I'm actually doing probably the last batch of this product. It's at the end of its life cycle, so I'm gonna make a bunch of these and then eventually show you how to switch it over to another mold. So here, I'll get started just showing you how it works. Safety first. As you can see, the machine is lacking some safety shields. Usually injection molder will have like a piece of glass in front of it. This one doesn't. It may have at one point in time, I've had things like the cylinders serviced, and pneumatic shops can still service them and replace all the gaskets and seals in them. So I wanted to talk a little bit about the controls. The controls are incredibly simple. It's pretty much just a 110 plug that plugs in here and into the wall, and it just comes into the back of this little box. This was actually an old floodlight I had, and I just used it for an electronics controller. This temperature controller I purchased on eBay for like $25. So of course the whole machine is grounded. 110 volts AC coming into the temperature controller. Temperature controller has a temperature probe. It's connected to the nozzle on the machine, and then it reads the temperature, and when it senses the temperature is too low, it sends a signal to the solid state relay to go ahead and turn on the heaters. So the heaters are also connected to 10 volts, 110 AC, and just switches on these two heaters. And the heaters are just these bands right here, 1 and 2. So really simple electrical schematic, easy to modify, easy to change. All the parts are readily available. You can order them, so incredibly simple. And the pneumatic controls are also very simple. I have here's my air valve coming in right here, and the air just comes up here through a filter to a controller, a pressure regulator, and this regulator controls the clamping force. So raising and lowering the pressure here affects the clamping force. And I'll document that, what PSI equals how many tons force. I'll write that all out. And then there's another regulator, a second stage. You can see it right through the injection molder here, and I just kind of look through the middle and adjust it when I'm working. But this one controls the injection force. So that's the pressure on this larger cylinder, and so those are the only two controls, and and the lines just kind of go underneath the machine and hook up to these two valves right here. And these are two-directional valves, so you can open and close either way. Extremely simple. There's just two valves, right here and right here, right here and here. Two valves. Each valve has its own pressure regulator. Switch it this way, the clamp opens, that way it closes. The middle, it just closes everything off. So, you know, really simple. So I'll include these I'll just stick them in a folder for anybody that wants it. But alright, starting with where the plastic goes in. This is the hopper. I usually just pour plastic in, to scoop it up and pour it in there. And I don't usually fill it all the way. I think that, I think one time it got kind of caught up in here when I fill it up all the way to the top. So I usually just keep, about a pound or two in there. And then the plastic goes in through the hopper, and it travels through this little mechanism here, which is really nice. There's another molder. I have another molding machine over here called a Morgan Press, and it doesn't have this this little mechanism here. It actually cleans off the plunger as it raises, and it keeps the plastic away from the plunger when it's not in use. So the plunger never gets gummed up. I've never had to take this mechanism apart. It's just always functioned perfectly. Anyway, the plastic travels down through this assembly and just falls into the barrel. And then when it's in this position, and then it's ready for a cycle. Then close the mold. That's with this one. Once it's closed and locked, you heard it snap. That's the lock. Then it's ready to inject. You saw it slide over when the plunger came down. The plunger just injects the plastic in. As soon as it was fully injected, I switched the switch over. That just relieves a little bit of the pressure on the part, and often people call that holding pressure. Anyway, once a few seconds has passed, that's enough time for the part to cool, and I can retract the plunger. And then on this machine, the plastic just falls down, so there's no need to pack it or anything. You could, before you remove the part, do it again and kind of extra pack the barrel, but I haven't ever needed to, and I'm making pretty big parts for such a small machine, so this is a good sized part. So now I'm ready to open the mold and take the part out again. So I'm going to remove this part from the mold. This is a hand insert, is what you call it, and it's fairly common in injection molding. What you do is you have the part kind of comes out attached to an insert that you have to remove by hand. This allows you to do pretty complex parts. Like this one has undercut on both, has a through hole undercut on each side, and that would be a really expensive part to make traditionally with using sliding mechanisms. Probably have to have 2 hydraulic sliding mechanisms to do it. But this way, I just did it with one part, and it just comes out molded to it. So how it works is you put the insert in the mold like that. This is a cell phone accessory for a phone that was really popular 2 years ago. It was called the N900, and I sold thousands and thousands of these, and it's just been extremely profitable for me. And it was fun designing the mold and learning how to use this injection molder. The only limit I've had on this machine, clamping force is I think around 5 tons, and so I had to go to a bigger machine in order to get a little bit more clamping force for the rest of the line on this. This is called the Game Gripper cell phone accessory. So I would like to sell this. See, this machine is fully hand operated, which is nice in some ways, but since after I started making this, I found that what I use this most for is really small parts without needing an insert, and I'd like to go to a fully automatic machine. I would like to upgrade to a machine called a Babyplast, and that machine is significantly more expensive than this one, but it's also much more complicated. And for someone getting started like I was, this was ideal. So and in the end, that's not what you want on your part. You don't want that screw. So the final part is to cut it off. For these rubber parts, it's easiest to use. I found a razor blade. So I'm just gonna real quick cut off a couple of these. These are the last few parts I made. You can see, it goes pretty quick. You can design a mold that doesn't have those, that is kind of cut off, but that's harder to do. So here's my last part coming out of the mold. So once again, this was an insert mold, and this was had a little higher labor because you had to pull the part out with it attached to an insert, and then pull it off the insert. But this was a very complicated part. It had holes on the sides, and it had a slight undercut. So it was a pretty complicated part. If you're making a simpler part that just comes right out of the mold, you can make a mold that just gets knocked out at the end of the cycle. So here's a mold for some test strips, and you can see the plastic comes in right here, goes over here through the runner and down into the part, and it makes a straight test strip and a test strip that's kind of necked down. And this is used for testing materials. But I got this mold with the injection molder, and I'm gonna pass it along to whoever buys it from me because I don't have any need for test strips. But the nice thing about this mold is once the part is done, you don't have to reach in there and pull it out. The ejectors hit this plate right here, and it just pops it out. See these little pins right there? Just knock the part right out. So you can see, boom. And then when the mold closes, it pushes these pins right here, and it pushes those ejector pins back. So this is kind of the bread and butter of the injection molding industry. So parts can just get cycle in, plastic in, part out, and it just does it automatically. So now that I'm done with this mold over here, I'm going to switch it over. Okay, so I want to remove this mold from the machine. I'm going to start by putting the insert back in there just so I don't lose it. And as you can see, there's a screw that goes right through, and this is kind of so you can adjust the length of this, or the position of this plate. And I want to unscrew this. When it comes time to do the other mold, I want to unscrew this, but this actually gets kind of stuck. The best way to get this tight, you tighten it after the mold is in there. You need to put on close the clamp. That's kind of a trick, and then it makes this loose. See that? Anyway, that's the trick to getting that loose, is to close it before you take the mold out and loosen this one up. Okay, so you should loosen those also. Okay, so that was the key. You also loosen these, turn them, and take these out, and loosen this back one before. Then you can knock that a little bit. You remove it. Okay, so now that that's out, this injection unit is in the way to pull it out. And this is actually really movable. So all you have to do is loosen these nuts up, and I don't always tighten all of them. There's 4 of them. They just hold it in place. So once those are loosened, you can just scoot the whole unit over and out of the way. Okay, so now that's out of the way, go ahead and remove the mold. So these plates right here, they're not actually part of the mold, they're part of the injection molder. And you'll design any mold you make to attach to these 2 plates. So you'll have holes to screw in. So I actually found that I only needed to have 2 screws, and these are just quarter inch, 1/4 20 cap screws. Okay, so this mold, I'm going to set it aside. This product I'm done with. I've made all the parts I'll ever need, I think, and so I'll just move on with that. So this is a mold for the test strips. And if I wanted to run parts on this, I could just bolt it up like that and put it in the machine and make parts for this one. But I don't need any of these parts, so I'm going to put it down. Now I do need some of these parts. This is another piece to this product, the Game Gripper. This makes the direction pads. So I actually do need to make some of these parts. So I'm going to go ahead and You notice I mounted this plate to this side. This side of this plate has holes right here for the ejector. The ejectors hit that plate and knock the part out. So just be careful and make sure you mount this side on this side if you're using a mold with an ejector. This one also has holes, but the holes are a little bit smaller, so the ejectors don't fit through them. So you gotta watch, make sure you don't switch them. Otherwise you have to take them off and put them back on. Okay, so now that it's in the machine, I just snug it up like that. Go ahead, close the clamp and just snug it up, and then tighten this one, and then you want to make sure that you get the most clamping force possible. So what you do is you go ahead and drop this pin in there. And tighten it up. And then move the barrel over a little bit. Put the other pin in. So kind of hold it in place. Now you want to make sure that the mold is closed when you tighten these. Otherwise the mold could be, slightly misaligned. This will just, they're all in there. You tighten these two and it just holds them right in place. So that every time it opens and closes, it's in the same position. Now what you do is go ahead and open the mold and then tighten this the nut right there. When that closed, it just closed without a popping sound. That's not good enough. What you want to do is tighten this up until you hear a pop. See, that time it didn't close all the way, so I adjusted this too much. Again, it didn't close all the way. So I'm going to loosen it up. Hear that? That pop? That means you're getting the most force possible out of your clamping mechanism. So now you know that this is adjusted to the right distance. You just kind of turn it back and forth. Either it won't close or it'll close too easy. It has to just pop in place, and then you know that that's the right distance. And then what you do is you just tighten this one up to keep it from moving. This is just kind of the final there. Okay, so now it won't move. It's just gonna pop every time. That means you have the perfect amount of clamping force. Now, the clamping force, part of it is the toggle, and you can adjust the pressure on this. Right now I have 80 pounds on the toggle. So I've gone as high as 100 with this machine. That's what the cylinder's rated for. But 80 seems to work just fine for most of the parts I have. Alright, so now you see the injector it's not lined up over the hole in the mold. So I just need to align that. It's kind of hard to do with one hand. Kind of look at it from both angles. Injectors all lined up, tighten these just to keep it in place. And sometimes it moves a little when you tighten it, so you gotta kind of compensate and close it again. Okay. Okay, so that's all lined up. The toggle is adjusted so that it closes the mold well. The last part is the ejectors. Now, all the ejector is see these two rods? They go through these holes right here, and they hit the ejector plate when the mold opens. So, and you adjust those just simply by turning this, and it moves them into place. So I'm going to go ahead and do that now. Open the mold, and I'll just turn these into place. You can see as I screw forward, see the ejector plate starts to move? Now you want to turn them both so they're the same distance. So that they both push. See that? It's pushing the ejector plate. And that's enough. You don't have to, it doesn't have to push it that far. So I usually just push it, just adjust these so that they just barely knock it out. Turn both of the ejectors so that they're the same distance. And then you can tighten these nuts all the way over, but actually I don't usually do that. I usually just leave it like that because they don't seem to move. So, anyway, now you can see how that ejector plate it moves back when the mold closes, and then when you open it, it knocks the part out. That's what, when it opens all the way, just pop. See those pins just come out right at the end? Okay, so I'm going to go ahead and turn on the heater, get this baby warmed up. Okay, so before I run this last part, I wanted to talk a little bit about this heater block assembly that I kind of built and improved while I've owned this machine. When I originally got it, the barrel was a 1-inch barrel, and it's still there. You know, you can see right there the actual barrel is only 1-inch diameter, but I put this this extra sleeve over it, and you can tighten it on the barrel with these little screws. Anyway, when I originally bought it, the machine, it had no heaters on it. You know, it was kind of, it wasn't functional as is when I bought it. And I originally purchased these heaters for them that fit the 1-inch barrel. But then I wanted to get better heat control and I found that the temperature would fluctuate pretty good with these heaters and just one temperature probe. So what I did is I added this extra sleeve that just gave it a lot more thermal mass, and I was able to stabilize the temperature a lot. And I just drilled and tapped a hole right here so I could move the thermocouple. It was mounted in the nozzle, so there's a hole in the nozzle. I think it'll be better to have the temperature probe right here, but if you want to move it, that's okay. You have options. And if you want to move it back down there, you have that option. Or if you want to have a more complicated heating system than this, you may want to add a second thermocouple and have one in both places. But this also just kind of shows how easy it is to take apart. You know, you can unscrew those, slide it off. The heater bands, if they burn up, are easy to replace. You just loosen a few screws, and then they just slide on. So anyway, that's that. Okay, so I got it all mounted up again, and it is heating. So I'm just gonna push these. I like to keep all the wires facing backwards. So I'm gonna need to purge the material out of this machine. There used to be some rubber. Now the next part I need to run is going to be a gray HDPE. Anyway, I've already emptied the hopper out, and so I'm going to go ahead and put some of this new material in the hopper. And then this machine needs to be supported. It needs a mold at all times. You can't just inject with the nozzle half supported like that. So what I do is I have this little scrap piece of metal from a different project that I just grabbed out of the scrap heap, and it works really well. So the nozzle has this little movable part right here. It's like a shut off. So what I do is I just reach in there and I push it up with the screwdriver, and I slide this piece under it. Just kind of put a screwdriver underneath the nozzle and push it up and slide this under it. There. And then with the nozzle, see, then the nozzle is supported, and we can inject. I always inject at a really low injection pressure. This will be the last purge I do before I switch over. See, there's still a black streak in there, but hopefully by the time I start making some good parts, the black will be gone. So you can see here the purge material. I started out with a black rubber, and it's slowly purged through to this this gray material, HDPE, that I'll be running this next part in. You can see it's pretty much gray now. There's still little streaks of black in it. But I'm going to go ahead and switch over and start making this new part, because I know the first couple parts are going to come out bad anyway. So by then, hopefully, I'll be fully convert it over to the new material and start making some good parts. Oh, I wanted to talk about waste. So this machine, you're likely to have more waste than a regular machine because you're operating by hand, and you know, you might go too fast, and then the plastic doesn't get a chance to melt all the way. So you kind of gotta, you know, get a rhythm going. But then, you know, if you have to go to the bathroom, the plastic might get too hot, or if you have to take a break or whatever. And so parts can come out bad. So here's just a couple examples. You know, here's a good part. You know, but the cavity doesn't fill all the way if the plastic isn't warm enough. So here's here's a part that it didn't all the way fill up. You know, here's another one. That one didn't quite fill all the way. The real part looks like this. See, so these are just duds, and they just don't all come out perfect. See, you just gotta plan on that not all of them are gonna come out good, and you get better over time. But and then some of them, there's other things that can go wrong. See, this one has like a shrink. That meant the plastic was too hot. And there's a lot of, there's a few things that can go wrong. Here's one that I forgot to put that insert in that I showed you. So it just filled that. The cavity was just a huge cavity in it. It just filled up. Anyway, all these are bad, and I'll just grind them up and run them again. That's the nice part about having your own injection molder. It melts the plastic and you can easily recycle it. So I'll just set these aside. Alright, so that's the machine. Now molds. I have a few molds here that work in this machine that I'll likely give to whoever gets the machine. But you're going to want to design your own. And I bought a book, but it was kind of like a textbook, and it didn't have real world. It was hard to kind of decipher what you really need to know. And I bought this mold book, and this is a great book. It's just basically the bare bones of what you need to know to make a really simple injection mold. So, and it shows you, here's a part, here's the mold, here's a part, here's a mold. It's just a really good book to get going. It's made by the people that sell this machine over here, the Morgan Press. So if you just Google that, cutting costs in short run plastic injection molding, it's a really good book. And then go ahead and get the textbooks too. There's several textbooks out there that show how to make injection molds.